All right. So good afternoon. I believe all in already. Okay. So recap back yesterday, not yesterday, Wednesday. On Wednesday, we actually learned some introductions in the multimedia. So basically, multimedia consists of main or five basic elements: the text, graphic, video, audio, and also the animations. And we also um, learn through the common system or common features in a multimedia system, whereas it is referring to acquisition system, storage system, the connectivity, the communications, and the processing part, which is the OS. So basically, this would be the very basic features in the multimedia. Of course, as I mentioned on Wednesday, it is very dependent on the application, but more or less would be around there lah. Okay. So we also learned about the linear and non-linear multimedia. So basically, linear is about like you're reading a book starting from A to Z, starting from A to Z. So you have to read from the start point to the end point in order to comprehend what is the content about or what is the information. So for this kind of media, we know it as linear media. And for those like the internet, you click on this hyperlink or click on this graphic, it will prompt another page and lead you to another information page. So those would be known as non-linear. Okay. So let's continue from the previous lecture. The classification of media element. Of course, the classification of media element could be uh, in many different dimensions. For example, um, you can view a computer from top and bottom view, maybe rear view, front view, whatsoever view, inner part and outer part. So it is very dependent on which dimension you wish to characterize or classify the media itself. So basically, previously we do learn about linear and nonlinear, right? So now we have discrete and continuous. So as per the definition itself, the nature of discrete is that like you are a male or female. So discrete, like you know, the digit 1, 2, 3, 4 is district. So all these kind like the color, like the color of the eye. Some people have brown color lens. Some with maybe blue color. So those are considered as district. So what would be continuous? Continuous would be sort of graph. So if you can plot sort of this kind of graph, and for this rate, you can only plot histogram. Okay, and value x, y, and z would be independent to each other. But for this one, it would be measurement, sort of maybe the height in cm maybe. So the distribution of height among the class, for example, 30 people. So you can plot the graph, something like this one. Okay, and also the marks of the examinations, you could have many A. For example, this is 100 mark, this is zero, many A in the class, or many fail in the class, or you have a moderate, which is a bell shape, something like that. So this would be what we call as continuous. So let us put the terms discrete and continuous in multimedia. So discrete, which means you can interpret the information by using uh, the information at this moment. So for example, you have a letter A. So whenever you see this alphabet, you can interpret, oh, this is an A. But for a video or audio, you cannot really interpret. For example, you have video, let's say you have a 60-second uh, video or audio. You cannot just listen to only the third second and you understand the entire meaning or information carried by the video or the audio. It is impossible. Like WhatsApp, you play an audio. Is it not possible for you to listen just the first 2 seconds or maybe just the 1 second in the very beginning of the audio or the video, and you already understand the entire information? So that is what it meant by the continuous. You need to continuous feed in or inputting the information so that you can understand the entire message carried by the media itself. Okay, so that is meant by the district and also continuous. So which means for district you can either have text, still image, and for continuous it could be audio or video, or maybe animations, because animation is sort of looping few images in a series, maybe 2 seconds, 1 second, something like that. So that would be the classification of media element. Okay, so discrete media refer to media involving space dimension only. So whenever you have an image, image is actually part of the signal as well. So I believe previous semester you already learned signal processing, right? So signal processing is, for example, the sound wave, all those are considered as 1D signal. And for images, it is actually a 2D signal. Okay, so why it is 2D? Because you have value from X and value from Y axis. So basically, you can plot an image in a Cartesian plan. Let's say this is the image. So this would be a 0, 0 point. It depends on the applications, because some applications this would be the origin of the images, but sometimes this would be the origin of the images. So it's very dependent on the origin, which means you have a value 0, 0. Let's say this is a 0, this is y axis, 0 until infinity, and 0 until infinity for x axis. Okay, so this is the coordinate lah. Okay, like a Cartesian plan. So it depends. Not a must every software or every tools, multimedia tools, it has the same definitions. Okay, but basically the general informations of the images is around that. Okay, nothing changed, because for example, Matlab, if not mistaken, I need to check back. Matlab read this as the origin, but for other software image processing tools, for example, Erases, it will read this one as, it will read the center point as the 0, 0. So towards here will be negative, towards here will be positive. So it is very dependent on how the software handle or process an image. Okay, so the example for district would be text, still image, and graphic. Okay, why I put a still image? Because images could be animation. For example, a continuous images would be animation. A continuous images would be animation. So it's best, to play safe, it's best to put a still image so that it is really emphasized that, oh, this is only involve the dimensions only, space dimensions. So it is also known as static media. Static has the same meaning, which means static, which means not moving, dynamic, which means moving. So either way, you can say a text, still image as a discrete media or a static media. And also for the video or audio, you can know it as a continuous media or a dynamic media. It's all fine. Okay. So it is also known as static or time independence. Okay. Another name would be time independence. Why it is time independence? Because the text, for example, alphabet A, it do not depends on the time to interpret the data. For example, the very first second until the very last second of the lecture, the A will remain as A. But for a video, the first second here and the last second, let's say it has 10 seconds, would be different. The content of the video or the image displayed by the video keep on changing. Same to audio. So this is called for audio and video, we call it as time dependence without this one, dependence. And for the text, still image, and graphic would be time independence, which mean it does not need to depends on the time to interpret any data. Okay, or else you can call it as the data do not change with the time, which mean it's independent. So continuous media is a time-dependent media, time-based media, because the data of this media change with the time. Example, sound, moving image, and animations. So video and audio data are sent as a continuous stream of packet that are being processed. The audio sample and video frames give meanings only when they are present on time and in correct sequence. This is very important. Although we all very familiar and video is something very common to us. So, but you have to know in order to play the video, the sequencing is very important. So video is not simply playing something else, but in order to give a specific meaning, the video, the frame, as I mentioned in previous lecture, the video consists of many different frames in 1 second. Okay, the higher the frame, the better the quality, or the better the higher the definitions of the video. So when you have HD video, so which means the number of frame in 1 second is very high. That's why you can see or you can observe many fine texture, many micro expressions of the actors or the cartoon itself. Okay, so which means you have a higher number of frame. When you have higher number of frame, which means you have higher data storage, the size of the video will be larger and larger. Okay, it's not possible for you to have a very HD video, but the size is very small, like one MB for 3 hours HD movie is not possible. Okay, the audio sample, okay. If there is significant presentation delay among subsequent frame or sample, the meaning of the content may be lost, delay sensitive, but loss tolerant. Okay, so which means all the frame must be in a fixed gap. For example, you have let's say you have um, 5 seconds. Okay, each second you have 20 frames. So let's say the very first second you have 20 frames, the second you have 20 frames, same to third second, 20 frame, fourth second, 20 frame, but the fifth one only 5 frame. So you would expect to observe a very laggy frame, like what we call lag when we load the YouTube, during the 5th second. Okay, so this is usually the number of frame distributed throughout the entire video would be the same. Okay, so this is when we have a delay, which means you have only 5 frames, so there is a delay over there. So you would observe a laggy or a blocky feel when you watch the video. Okay. So continuous media does not need to wait for the whole data to be transmitted. So streaming is usually employed when sending continuous media across the network. It is like the OBS lah. So when we broadcasting something in the live video, so the data would be streamed continuously, sort of first in, first out theory. Okay. So this would be the overview of the multimedia. So first of all, you have multimedia data. So you can characterize it as discrete or continuous. And then in discrete and continuous, in discrete, you have text, image, still image. In continuous, you have audio and video. And then interactivity, okay, it depends. Basically, text, image, audio, and video could be interactive and non-interactive. It's very dependent on how the user integrate, use the text or use the image itself. Okay, for example, I can just type like your thesis, like your FYP, your capstone, your thesis on technical report. You can actually just type in the text, so it is just a linear media. But when we view it in PDF file, in soft copy, you can actually put in hyperlink. So text can be converted to hyperlink and become interactable. Okay, so application would be for this one would be book slideshows, and for interactable laptop browsing, same to this one. Okay. So capture versus synthesis media. Capture media refer to information types captured from the real world. So which means like a video recorder, like a mobile phone, you open up the camera and you capture the video. But for synthesis, it's something like I like in your I believe you all been using Matlab since you are in the second final semester. Maybe some of you are doing image processing. So basically, you can actually code up in Matlab. You can code up text, not text block, but sort of figure, and then you feel maybe this is one. This is the original 00 until 10, until 10. This is the x-axis. This is the y-axis. So maybe you want to fill 0, 0 until 1, 2, 3, 3, 0, and 0, 0 until 0, comma 3. You want to fill this block as black color, which means this is black color. This is white, black again, white, black again, black again, black again. So you can actually create this kind of synthetic images using the Matlab. I believe not only Matlab, many other different image processing software, you can do it. So all these kind of images, which is created by declaring the specific intensity value for a specific coordinate in an image. So basically, this we call it as a synthetic media. So for the capture media would be the video that you capture all the while. So example would be vector graphic and animated graphic. Multimedia data representation. The common medium used in multimedia data representation would be text, image, vector graph, audio, and video. So this would be the basic element for multimedia. So for text, static data or media, proper use of text and words in multimedia presentation will help to communicate the idea and message to the user. Huge gray block of text can be boring to read. Basically, I think this slide is a bit common sense. I believe you're all very familiar with what text is. Okay, so basically, during presentation, you would want to put everything, of the text, fill up the entire slide of your PPT so that it wouldn't be so boring. So maybe you can add in graphics, especially when you present your FYP. You need to put in tables, figures, chart to illustrate, and also to enrich the data, illustrate the data, and also engage the panel. Okay, so this would be this is the example of choosing different fonts. So as you all know, we have many different fonts like Calibri, Times New Roman, many different kinds of fonts. So for this news, in order to differentiate, because in the very, very old, back to maybe 1950s something, they don't have any graphic, even black and white images. No, they only have text. So they will put the text in different fonts, different typography. So like this one, this is different font, this is different, this is different. You can use a different size, different type, different design to make to highlight a specific informations, or to represent the content, or to highlight specific phrase like using bold, underline, italic, something like that. So the main concept with the text is readability, where basically, as you can see, the FYP thesis itself, for thesis preparations, it has different template. Not different template, just one template. But inside the template, you have different alignment for the figure, for the table, for the captions, the main title and the subtitle as well. So the main concern is to emphasize and also promote the readability lah. Okay, although fonts could maybe attractive. This one because it says consists only 3 words, it's fine lah. But let's say it has up to all these content using this font, then would be very confusing. So filling the screen with text or reducing the size of the type to accommodate more text might prevent readability. At the end of the day, we don't want just put everything in the slide, in your slide, and then actually the panel not really able to read it. So it's not really useful. I mean, the intended function is not avoided. So during a presentation, always I would prefer the student would have many slides, but all the slides, in each slide, the readability is high, which means you don't have many words in one slide, maybe few sentences with sufficient gap, and also with the graphic table where applicable. Okay, so but it's okay to me. A high number of page with good readability is better. Okay. So about the fonts, typeface, also known as fonts family, indicates a family of character or letter which have similar look. Typeface, so you have 2 different typeface, serif and sans serif. So serif, the example would be Times New Roman, Palatino, yeah, Georgia, and for sans serif would be Arial, yeah, and etc. Okay, a font is a particular size, weight, and types of the typeface. Okay, typeface is important. A serif is a line or curve extended from the end of a stroke of a character. So this is known as serif font. So basically, you have an F like this one, right? So it has sort of a very small patterns over there, like decorative patterns, extend from the end of the character. So this is known as serif fonts. And for sans serif, which means sans, the definition of sans is without. So serif is the line or curve. The definition of serif is line or curve. Sans is without. So for sans serif font, which means without all those decorative curve and line. Okay. So a serif is a line or curve extend from the end of the stroke of a character with little decorations at the end of the character. So a French word sans means without. Therefore, sans serif without the curve. Typical typeface is one without serif, without decoration. So this is a serif font, which means it has all those decorative. And sans serif, you have none. Okay. So the red color one would be the one different between A and B. Okay. So comparison of typeface, serif and sans serif typeface types. So as you can see, it has, although a little bit blur, you still can observe that is sort of line, leading you. You can, when you view both this example, you can feel like this is clean, but this one is it has sort of line leading you to read the words. Okay, yeah, this is serif and sans serif. So the comparison of typeface, for series type, create the illusions of a line along the base of a line of text and guide the eyes. And also, serif fonts are easy to read on printed page, so they are usually used when there is a lot of text to read. Due to the low resolution and computer screen, serif fonts are difficult to read than sans serif. Example, Times New Roman, Bodoni, MT, and Bookman. And sans serif type, sans serif text is clean. As I mentioned just now, it is very clean without any decorations, simple and project rationality and objectivity can be applied in presentations on screen. Usually need for headlines and title, providing a contrast with a serif font or for text. So usually, sans serif is used as the main title. The reason why is that it is very clean, um, easily to catch the attention of the readers. And serif usually is used in printed material, and the decorative line make it easier. I mean, it is sort of guidelines to guide your eye to read the entire sentence, rather than, when you read a newspaper, you won't read from first line and then you read to the second line. So that is the purpose of serif over there. I mean, the main purpose is to guide your eye to read the entire lines and then continue for the second one. Okay, usually used for headlines. Okay, the example will be Ariel, Verdana, and Helvetica Tahoma. So text can be composed of character or symbol. Of course, text is not just alphabet. It consists of symbol like comma, full stop, etc. Character data isn't just alphabet character, but also numerical character, punctuation, spaces, special character, and etc. ASCII, American Standard Code for Information Interchange, is the most common format for text file in computer and on the internet. So in the ASCII file, the character data is represented with a 7-bit binary number with 128 possibility character are defined. So this is an example of ASCII code in decimal. You would learn this. Let me think. Maybe when you do the programming, then you may need this. Else, I think, not so sure. I think programming in depends on which type of language you're using. Some language may require the ASCII definitions, the ASCII code. So a universal code character set standard Unicode is a universal character encoding system designed to support the character or symbol from all language worldwide. So a character set consists of character, each assigned with a unique code. The standard ASCII character set only support 128, and whereas the Unicode support up to 1,000 character. ASCII only use 1 byte to represent each word, whereas the Unicode support 4 byte. So basically, the higher the number of byte, it can support a huge variety. That is because byte is closely related to bit, and bit is closely related to the storage. Okay, so that is why you have MB, TB, those, right? Image vector graphic. Information communicated through images are easier to remember and understand. So input source, digitally scanned photographic picture direct from a digital camera generated on a computer. Compressions of image is commonly applied for transmission and presentation. Compression of image is kind of important in this in this MTAA. That is because we always deal, as an engineer at E&E, we always deal with especially for electronics, we always deal with the images. So, and the image augmentations, image processing is becoming the mainstream, I would say. So that is why face recognitions, any processing, they are trying to use the image instead, like the security face recognitions, like the semiconductor, to use the camera, the image processing to detect the defects on the die, the PCB board, and the end product. So end product like pharmaceutical is the expire date being printed correctly, to observe the water level in any beverage. Is the water level is good? They are not going to measure the ml. Of course, when during the production, they will, of course, this machine itself will measure the ml. But later on, they will put in a conveyor belt, and then there will be another camera here to capture the water level of this bottle. You might be very curious, for example, water bottle like wine, like sparkling juice, all those, how they even do it with, with the water bottle. The glass bottle is very dark in color. Of course, they would have their very specific light source to snap the images to create a very suitable image acquisitions box over there, usually black box. Okay, we call it a black box because usually we don't want ambient lights to interrupt the image acquisitions part. Okay, so that is why so do not, I mean, do not just think that the image processing is only in E&E. No, even in pharmaceutical, the agriculture, everything is using the image processing as well. So it's very important for you all to know at least the image processing part, so that later on, even when you interview for jobs, you can actually say that, oh, I know image processing, this and that. You can bluff a bit at least. Okay, so last, I think back to 5 to 6 years ago, we don't have computer vision engineer. I mean, as far as I concerned, I never heard of this position. But recent year, starting from grid tech, I think grid tech do take employ vision engineer, or some put it as computer vision engineer. And then later on, there is more and more industry player follow the trend, like the Panda Master, the MIE, Vitrox, and many more. So they use this very fancy word, the vision engineer. Okay, but as far as I'm concerned, we don't have any bachelor degree which just focus in image processing. So usually image processing is included as an elective. So it's very important for you to learn this in MTAA lah. Okay, MTAA is about image processing as well. Okay, digital image are usually divided into two categories: bitmap, or we call it as raster, or vector graphic. So as I mentioned previously, the bitmap or the raster image is actually built up by using pixel by pixel. It is exactly like the Cartesian plan. For example, you have, okay, this is 0, 0, 0, 1, 0, 2, 0, 3, 0, 0, 1, 0, 2, 0, 3, 0, and so on. Okay, so for each of this one, 0, coordinate 0, 0, maybe you have intensity 0 or 1. Let's say this is a black and white image. So 0 is representing black and 1 is actually representing white. So because this is black and white, so it's only have 0 and 1. Okay, either way. So all, whenever the images with pixel value, so it is considered as bitmap. Okay, but for vector, it is a bit different because vector is not um, defined by using the pixel. The vector is defined by using the equation. That is why whenever you zoom in or zoom out, the equation is always there. For example, y equal to mx plus c. This is a very common mathematical equations. So you can substitute any value for x as long as you has the value for m, and c value. So you can actually put in the x value to calculate the y value, or put in the y value, calculate the x value, and vice versa. Okay, so vector graphic is always defined by the equation. Of course, not this equation. This is just an example. Vector is defined by the equations, so it would be always displayed at its the best state. So whenever you zoom in, of course, whenever you zoom in, you can have a better, I mean, the vector would have a smooth edge, not like this one, blocky feel. Because why? Because whenever you zoom in, you can see, it is one block, one block, one block. So from this block, it is actually declaring, okay, this is light gray color, light gray, light gray, light gray, dark gray, light gray, okay, black, 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 black. Okay, that is why it's formed, sort of this staircase feel. But when you zoom out, it is actually okay at least you can see the word VS okay. But for this one, for the vector, it is defined by equation. So whenever you zoom in, it will always show the best definition, best resolution. Okay, I don't want to use this as an example because even this image is a bitmap. Okay, that is why you can see blocky field here. But when I show you the words from the PPT itself, you can see even when I zoom in the max, the edge of the alphabet is very clean, very clear. So obviously this is vector lah. Okay. So whenever we present anything, we would prefer, especially in your technical paper, your thesis, your anything, meant for presentation wise. So in my personal, I would prefer vector. So because the image is clearer, okay. Else you can use I think called DPI, dot per inch. So at least 300 DPI. Okay. Uh, yeah. So this would be the basic requirement for most of the journal. But in order to process the image, then for sure we will go for bitmap. Okay. We don't really process vector image. We process bitmap image. So bitmap or raster image are stored as a series of tiny dots. So this tiny dot, where it can be represented using the Cartesian coordinate, for example, 0, 0, 0, 1. All these coordinate, we call it as pixel. Each pixel is actually a very small square that is assigned a color and then arranged in a pattern to form that image. So the color depends what type of color is it. For example, black and white image. So you will have intensity 0 or 1. Let's say you have a gray value, grayscale, so it's 0 to 255. Okay, so 0 is always black color, 1 or 255 is always white color. Okay, and you can always normalize this one to this scale. For example, 0 to 255, 0 to 1. You can always normalize this value to, arrange, normalize this to, to get a value between 0 and 1. Okay, basically you just divide by 255. For example, you have 170, 160, 150. Oh, I want to normalize it to get this value. So you divide by 255. Then you will get sort of value which is between 0 and 1. Okay. To perform this one, whenever you change or you amend the value to convert it to fit into 0 and 1, we know these techniques as normalizations. Okay. And vector graphic make up of many individual scalable objects. These objects are defined by mathematical equation. So that is why for vector image, a vector graphic or vector image, it is always very clear. So both bitmap and vector graphic looks the same on the screen, but when the bitmap is enlarged, it will blur and the pixel will get enlarged as well. That is because it depends on the pixel as well. The higher the higher the number of pixels, the clearer the image. It is the same idea as the video. As the higher the frame, the more the higher the resolutions of the video itself. The same thing. So that is why when you have a HD video, when you have a UHD video, Ultra HD video, so the number of pixels will be increasing. So when the number of pixels is increasing, so the more pixel can be used to represent a small things. For example, you have only one line, but when you enlarge the line, actually the line is dark at the center and very gray color at the edge there. So this is how you actually represent it. Likewise, if you have a 3x3 block, you will only, you cannot display a circular shape. Let's say you want to display sort of circular dot. If you have only 3x3 pixel, which means only 9 pixel here, is not possible. So the black color dot here would be representing this one. Okay, but when you have a very, more pixel, so it can represent, this dot better. Of course, what I draw now may not be the better one, but just to let you know, okay, at least you can see your sort of circular in shape, but this one just one dot. Okay, so which means the higher the pixel, the more flexibility it has the pixel has to represent a single object. Okay, so that is why when you have HD video, UHD video, HD TV, UHD TV, you would expect the TV itself would have more and more pixel. Okay. The vector image looks the same when enlarged. This is because it is defined by the mathematical equations. This is because the data is stored in a mathematical form and the value are recalculated when displayed on the screen. So since the value is recalculated during your enlarge, I mean, whenever you enlarge, the vector image will keep on recalculate using the current fit-in image, fit-in value. So it will display the same. Both types of image are stored in different file format. And typically, these file formats are compressed to save memory space. Bitmap file formats such as GIF, JPEG, PNG use compression within the file itself. So the extension is actually extension of a file, no matter words file, text file, graphic files, and also video file. It's actually telling you the format of compression, the method of compression it is using. For example, if you want to remove background, usually it would be saved in .png. And if you want to save it as a animation, so usually it's .gif. And for those that you want to save it to reduce the space, for sure would be JPEG. And if you don't want to compress anything else, then you better to save the image in .tif or .bmp. Okay, and for vector, you can have .svg. Okay, usually .svg is referring to vector image, and whenever you double click the .svg, I don't think, I mean, for the decent image viewer file in the computer won't be able to view this one. For sure, when you use color specific application, for example, color draw, then you can view this image. Else, this .svg will open using the Microsoft Chrome, or the Microsoft Edge. Okay. So this would be some commonly used image format are described in the table below. .bmp, .gif, .png, .jpeg, or .jpg, .psd, and .tip. Okay, so respectively, bitmap, graphical interchange format file, portable network graphic, joint photographic expert group image file. Joint photographic expert group is actually sort of committee to decide what types of algorithm being used in this JPEG. Okay, JPEG is very, very common to all of us. Just that actually JPEG is actually known as the joint photographic expert group. Okay, is a expert group which is very, very expert in image processing. So they would decide what algorithm would be used to save or to optimize the compressions of an image. Okay, so Photoshop documents and tag image file format TIF. So applications for this one, bitmap, uncompressed image file used to store bitmap digital image. So some of the medical image, because this file is not uncompressed, which means it's saved as per the original image acquisite from the acquisition stage. Okay, whenever you snap, so this would be the original uncompressed image. So this uncompressed image is very bad. I mean, an ideal case. I mean, and it's very ideal for image processing purposes. So some of the images will be saved in .bmp, and .bmp, for example, the breast histopathology image can be saved in .bmp. So it's but of course the file size is quite big. For one image can up to 1 MB, one image only. Okay, so GIF common for web graphics with small image and images with text, use limited number of color. So for this one, it is more like animation, short animations, maybe 1 seconds can change like the GIF you're using in your IG and also the Messenger. .pmp used to support graphic for web image and support up to 32 bits color. It was an improve of GIF. So for JPEG, common image format used by digital camera, support up to 24-bit. And PSD, image file created by Adobe Photoshop, and TIF, highly flexible and platform independent format, which is widely used today. Okay, so this is uh, I mean, some images are saved in TIF as well, so it's fine for you to process the images. But yeah, it's okay later on. Bitmap raster image shows with different resolution. Resolution is like your computer, you can always change the resolution. But whenever you change the resolution, you may have a very weird display from your computer because the current resolution may or may not support the current monitor size. Okay, so resolution is actually the number of pixel at y and also number of pixel in x lah. Okay, so it's like a Cartesian plan, y axis and x axis. So basically, resolution would be y times x lah. Okay, for example, this is 200 times 200, so 200 times 200 would be your resolution. Okay, so the image quality improved when resolution increased at the expenses of increasing image size. In order to save more data, so you need more spaces. Okay, just like you have one box to keep one apple. So now you have 10 apples. So you would expect you have 10 boxes. It's impossible for you to have one box to keep all the 10 apples, right? Okay, so the same thing. So this is only one timer, which means only one pixel here and one pixel here. And this is 2 times 2, 1, 2, 1, 2, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 10, 10 over here, 20, 20, 50, 50, and 100, 100. So as you can observe, from here to here, the image color, I mean, the resolution would be increasing, and the value, I mean, the alphabet R, and as well as the background, the contrast would be increasing, because for this one, 100 times 100, you have 100 times 100 would be how many? 100 times 100, okay, would be 10,000. You have 10,000 pixels to represent the entire image. But for this one, you only have 1 pixel to represent. And for this one is, and for, yeah, so this is increasing value, increasing, not value, like increasing the number of pixels. So the more the pixel you have, I mean, you can display the details in a better, using a better resolution and using better, I mean, more and more pixel. So vector graphic are usually generated by a graphic editor program such as Adobe Illustrator. Vector graphics image can be zoomed and manipulated without affecting image quality. As I mentioned before, because it is defined by the mathematical equations. So whenever you enlarge or zoom in, so it will redefine by recalculate the mathematical equations. It is constructed by the composition of primitive sub-objects such as computer-generated lines, polygons, circle, curve, and arcs. Okay, so this is I don't think this is an example lah. Okay, bitmap raster image versus vector graphic. Okay, so the first column at the left-hand side will be the bitmap, and the second column at the right-hand side will be the vector graphic. So here are some of the formats, and these would be some of the software. Okay, yeah, color draw is over here. Audio. So sound is used in analog form, and the digitized form of the sound is audio. Okay, so I believe sound and audio would brings I mean, very similar meaning. But whenever we mention sound, it is referring to analog, and when we mention audio, it is referring to digitized. I mean, being converted to digital form. Okay, so audio and I mean, sound and audio, the analog and digital is a little bit different. Why? That is because the sound would be natural something like this one. Okay, it is sort of non-linear graph lah. Okay, but let me draw in a simple way. Okay, let's say this is the sound. Yeah, sound wave. So in audio, you have to digitize this one. How? By putting sort of value, assigning a value to them. Okay, and you form sort of histogram. So after the histogram, not sure if I can remove this one. So after the histogram being formulated, this would be the audio, and this is the analog, Analogue, or sound. This is audio or digital. Okay, so this will be the difference. In digital, you must have a specific value for a specific time second. Okay, but you would expect when you convert from analog to digital, you would expect a minor loss of data. It's very dependent on the sampling time. Okay, because when you compare with the original time, the analog time, so you would expect you will lose data somewhere around here. This gap. All these gap are the data that you already lost. Although the loss is very minimal, but it still have a loss over that. So when you have a very low data sampling, for example, you only have take 3 sample, you know, 1 sample, 2 sample, and 3 sample. So you will have a greater loss lah, over here, here, here. So this is when this is the way, I mean, the portion where the data will be lost when you convert from analog to digital. But again, usually we will process the audio or process the image only in digital form. Okay, so that is why we will need the conversion. But we also need to be very careful on the sampling size. So for this one, you will expect a higher sampling. For this one, it's very low, only 3 sample taken. Okay. I will explain this more in later chapter. Okay, don't worry. So sound is usually recorded by microphone and digitized to audio for storage. Hardware used would be microphone, speaker, audio file can be edited by deleting some part of it, change the playback speed, change the playback volume and echo and etc. So whenever we record for example, you record a voice message using WhatsApp and you send to your friends. So nowadays, WhatsApp can play the audio with uh, 1.5 or 2 times the original speed, right? So it's actually converting the sound wave to, I mean, the analog wave to digital wave, which means you convert from the sound to audio. And then later you send this audio to your friend, and when your friend play it, it can actually, because it is already in digital form, so the user or your friend can actually speed up the speed to play the audio and become 1.5 or 2 times the original speed. Okay, so this is actually the difference over there lah. And whenever you speak, I mean, we can listen our voice, right? But when you speak the voice using the via the telephones and etc., there would be a bit different from the real voice. So this is the loss of, I wouldn't say the loss of data over there, but there would be a discrepancy over there, because the message is still conveyed as it is. For example, oh, let's go McDonald's later on. This message will still remain the same and send it to your friend. But the intonation there, the pitch over there would be a little bit different. So I would say there would be discrepancy in many factors regarding your message. But the main purpose, I mean the core message that you want to carry to your friend would remain the same. Okay, if uh, I I record a voicemail, let's go McDonald's later on, and then send it to your friend, and then what your friend listen at his or her end would be, let's go to KFC. Then that would be a wrong message lah. Okay, it's very not unacceptable. Okay. Okay, video. Video refer to the sequence of natural scenes captured using analog or digital video capturing device, which often in relatively high frame rate. So this frame is what I mentioned previously. For we have different frame number arranging in a specific sequence. So whenever we have something else arranging in terms of time space time dimension, so we will call it as rate lah. Okay, like the rating for you to for your marks and this and that. Rate is something to measure against the time taken. Okay, so more than 15 frames per second. FPS is a very common terms in video, which referring to frame per second. Okay, so this device can be a web camera, digital camera, or even a mobile phone. There are two video format, analog and digital. Analog video is usually captured by a video camera and then digitized, and then digitize using some software. And digital video, however, need to be compressed for most of the time. So transmission rate of video is described in frame per second FPS. So this one is important. They are typically 25, 30, 50 frame per second. Above 15 FPS, the human eye cannot see the single frame and is strict in seeing a smooth motion. So this is the basic principle of a video. Video is actually arranging the images, but in this case, we call it as a frame in a correct sequence. Because the changing of this frame is very smooth and is too fast, so our human eyes cannot capture the discrepant, I mean the gap between first and the second frame. That is why we see the video, or we watch the video as a continuous motion. Okay, seems like it is the theory is same like the light bulb. Okay, actually the light bulb is keep on flashing. Okay, but the flashing speed is very high until we observe it as a single and still light emitting from the light source. Okay, so the common use video format are shown in the table below. This will be the common video extension, for example .avi, .mp, .mpeg, and etc. So I don't think I will go through the entire table. You can refer this later on. So basically, different video extension would have different intention. Okay, and it is invented by I mean specifically for different purposes lah. Okay, and we don't really have the best video extension, or for example for audio as well and for image as well, we don't have a best extension. It's very dependent on your application. Let's say you want to save the image, store the image, but you don't need a very high resolutions image. So please select JPEG. So let's say you want to have something without the background, please select PNG. And let's say you want to hold or to remain all those crucial details in one image, please select .tif or .bmp. So that is different application. You have different so-called the best extension for that particular application. And this is the common audio format. .aac, .mp3 is very common, I believe. The rest of it maybe not so common to you all. Perhaps .wma is common as well. MP3 will be the most common. Okay, I believe last time, back to maybe 10 to 20 years, we do have MP3, right? Like the iPod, all those things. Yeah, those are MP3. Okay, summary. So in traditional method, the information is conveyed only using only the text, while in multimedia, other elements are used along. the information is in form of text, sound, picture, and etc. to convey meaningful content. Okay, so basically, uh, let us recall back. Basically, for this chapter is very direct lah. Okay, the main point that you need to know would be the basic element in multimedia: text, audio, image, graph, animation, and also video. Uh, Classifications of media, you have two types. The first one, linear and non-linear. The second one, discrete and continuous. So either you can call it as discrete, or you can call static or time independence. And for continuous, you can call it as dynamic, you can do as time dependence else. Okay, vice versa, it's okay. Okay, then later on you learn the typeset, the series and sans serif. When would be, I mean, the common application of serif, common application of sans serif. You learn about bitmap and also the vector. When, I mean, for what purpose we usually use raster image or bitmap image, and in what reason we usually use the vector image, and how the vector image is being formalized. And also we do learn about the common features in the multimedia system. So the acquisition part, the data storage part, the networking or communication part, the processing, which is the OS. And always remember the definitions of multimedia. It is consists of multiple and medium, and both of these put together, and not just simply put together. It must, I mean, multimedia is about the interaction between this media and engaging the human senses. For example, your eye, uh, your nose. I mean, like the dimensions, like the movie, 2D, 3D, 4D, and 5D, engaging your senses and etc. Okay, so basically, this would be the basic introductions to multimedia. But bear in mind, and this is just introduction. Okay, uh, for your information, this MTAA, the main the main knowledge or the main informations, main slippers would be surrounding the image processing, audio processing, and video processing. Okay, so you, in the subsequent chapter, you will learn about image processing, audio, and also image. The same thing for your practical and also the assignment. Okay, so for chapter one is really about the introduction only. Okay, so any question from the floor? No. Okay. It's too quiet. Oh, okay. Uh, whenever Usually, whenever you don't have any question, I would expect either you know everything or you don't know everything. Okay, but it's okay. Now it's just the first week of the lecture. Um, yeah, we will see later on. Okay, so perhaps we can take five. After take five, we will start chapter two. Okay, chapter two already uploaded to the Google Classroom. You can retrieve the lecture notes on your own. So let's take five now. Is 2:09. Perhaps we can back here in 2:15. Okay. Okay, welcome back. So let us continue to chapter two. Chapter two would be, I think the arrangement of the lecture notes would be image processing first, and then followed by audio processing and then video processing. So the core would, I mean, the core, most of the chapter would be regarding the image processing. Okay. So for chapter two, we will learn the fundamental in image processing, um, typically how image is being formalized, what is pixel, this and that, the black and white, the color images, the RGB, yeah. Okay. So this would be the table of content. Digital image representation, image formation, type of image, image quality, uh, which is the resolution, the one that we mentioned just now. The image storage size, color vision, color perception. Please be remind that actually for all the image processing, no matter image processing, audio processing, and also video processing, it is regarding the senses of our eye, senses of our ear, and also yeah, more usually eye and ear. Eye is for the video and image, and ear is for audio. So it is exploring the limitation of human. For example, we cannot hear a very high pitch sound. So during the compressions, we will tend to remove all these high pitch sounds intensity to save up space. And the same thing, we cannot really we cannot really see high resolutions or high frequency object in an image. So during the image compression method or video compression, we tend to, the algorithm tend to remove these high resolutions informations, and we still can preserve, we still can preserve the original data. For example, the image show you an apple, a red apple. After the image compressions, for example, it is from bitmap image convert to JPEG image, you're still able to see or view it as an apple. But instead, maybe this apple is not so high resolutions, a little bit blur at the edge of the apple. The red color, the resolution of red color would be a bit dull and etc. So this would be the different, uh, exploring the human limitation there. Perhaps it is a bit confusing for you now, but take this as a very brief introductions for you all, and then later on you all will understand why. How is this being uh, conducted, being performed, implemented in the compressions for image, video, and etc. Okay, an image is a function of a space. You all know function, right? F, X, Y. This is function. Okay, I think it's very common to all of you about the functions. So the function of space, why it is about space is because you have x and y exit, x exit, y exit. So the coordinate 0, 0, and continuous until infinity, and downwards until infinity. Okay. Again, this is not a must the origin for all the all different software. Some software may define this one as 0, 0, or we call it as the origin. But sometimes the software would define the center point of this image as the origin 0, 0. So you have to understand the uh, principle behind the software, how the software process a particular image in order to um, maximize the image processing experience over there. Okay. So an image is a function of space. Why it is about space? For example, the very first, we use back this example. So the origin, it would be here at the top left corner. So 0, 0. So for example, you have 0, 0, x is 0, y is 0 as well. The intensity is maybe 100. So the function of this space value is 100. Okay. Why it is called a space? Because you has x exit and y exit. So when you have two different exits, so it create a two-dimension data. Okay, or what we call uh, two-dimension signal. Okay, but anyhow, we still can convert the space into one dimension during processing in Matlab. How? We can actually convert it like, let's say you have a 3 times 3 pixel. Uh, you can call it as 1, 2, 3, 4, 5, 6, 7, 8, 9. It's fine to process in this way. I mean, in Matlab. Okay. There would be some tricks over there. Lah. Okay. And sometimes you can call it at 0, 0, 0, 1, 0, 2, 1, 0, 2, 0, and then 1, 1, 1, 2, and then 2, 1, 2, 2, something like that. This is for space in 2D form, which means Cartesian plan, exactly like the Cartesian plan. Okay. So an image may be defined as two-dimension function, fxy, where x and y are spatial coordinate. Spatial is actually spatial is about the space lah. Okay, so whenever you have spatial, which mean you are talking about information dealing with the space. For example, the information with regards to first pixel and the second pixel, first and the third pixel, and etc. So this is known as the spatial lah. Okay, any information dealing with the space. And the amplitude of the f at any pair of coordinate xy is called the intensity of glare level of an image at that point. Okay, amplitude, which means this would be the amplitude. For example, we have a 0 to 255. Let me draw here. Let's say you have 0 to 255. So the total number, let's say you have 3 times 3 lah. This is 0, 100, 200, 0, 100, 100, 0, 100, 100. Okay. So you would expect your graph, this would be the frequency or what we call amplitude. And this would be the intensity. So since you have 3, 0, you would expect 1, 2, 3, 4, 5. Okay, you would expect to have 3. Let's say 100 is over here. 5. 200 is here. 200 got how many? 1. Okay, this would be your graph. I mean your chart for intensity histogram. Okay, why? Because you have the total number of pixel would be 9, right? So you have 3. You have 3 0. So you have 1, 2, 3, 4, 5, 5 hundreds, and also 1 200. Okay, the rest is does not appear anything lah because it is 0 ma. Okay, so this would be your amplitude. And we call it as frequency as well. And sometimes you want to call it as amplitude also can, up to you. Okay, and this is the intensity, which is ranges from 0 to 255. Why 0 to 255? Because this is the maximum number of bits. Okay, so when x and y and the amplitude value of f are all finite, this is called a digital image. Finite, which means it has specific value lah. Because your TV must have a specific length and height, right? It's impossible your TV is infinity, right? Infinity, which means your TV without any specific length or specific height is not possible. Any image is the image must be a finite image. Why? Because for sure the image has a fixed resolution. For example, 200 times 300, 400 times 500, maybe 1000 times 1000, something like that. You won't have an infinity times infinity. Is not possible. Okay, so for sure the image is finite. Okay, So this is an example, and this example I believe is from based on Matlab lah. That is why the origin is here. This is the origin, and then towards down here is the y-axis, and towards the right-hand side would be the x-axis. So the pixel would be, a blocky shape lah. Actually, it's distributed all over the entire image. Okay, entire image. Okay, for a particular coordinate, you can call it as x value here, and y value here. Okay, so that is how you get the coordinate, like the Cartesian plan, exactly like what you learned last time for the Cartesian plan. So a neighborhood of psi 3 times 3 center at a point x, y in an image. Okay. So pixel define the element of a digital image. This element can also call a picture element or image element. So pixel is the smallest particle in one image. You can actually call it as a picture element or image element, but normally we call it as a pixel. But bear in mind, three of these terms could be interchangeable, but the common one would be pixel. Okay. A digital image is composed of a finite number of elements or pixels, each of which has a particular location and value. For sure, it would have a specific coordinate, because for sure the image would be defined by the range. For example, 0 to 100, 0 to 100. For sure, no matter what point is the pixel located in one image, it for sure has a particular location. So this would be the particular location, and for sure it will has a value, and the value must be 0 to 255. Even it is black color or white color, it is a value, because 0 is for black, 255 is for white color. So representation of bitmap image. So this is one of the example image. So this is the column. This is the row, which is x-axis and y-axis. Pixel value at the location 10. The 10 column. Column number 10. This is column number 10. And this is row number 4. It's 110 grayscale color. So I is the functions for 10 equal to 1, 1. Okay, so row first followed by the column. Okay, again, this is a bit tricky. You have to not all the software has the same definition. Sometimes in this case, in this example, would be row column, but in some example would be column row. So please do check with your software. Depending on which software you are using, do check on this one. Don't just use whatever the lecturer mentioned, because some software may have different principle to process the image. Okay, so either way, you can use f, I, whatsoever, just to represent the functions, and this would be the coordinate x and y, and interchangeable either way, and equals to 110. 110 would be the value of intensity. Since it is grayscale, so it should be 0 to 255. Okay, if you want to normalize, it should be 0 to 1. Okay. A two-dimensional array is represented in a matrix form in Matlab. Okay, so basically, not only Matlab, I believe most of the image processing tools are representing the image in a two-dimension array, or what we call a Cartesian plan. Okay, the image resolution is m times n, where m refer to row and n refer to column. So basically, this would be the way the Matlab is reading. Basically, when you let's say you declare an image, maybe A is equal to im read maybe pebbles.png. Okay, then the pebbles will be stored in A, and then you can A underscore gray is equal to RGB to gray, and then A then which means you convert this A to grayscale. So A underscore gray will store the grayscale image of this one. And then whenever it is ready, this would be your interface. My interface is like that lah. Okay, the algorithm is here. So all the declare stuff would be here. So let's say the A underscore square is here. So you double click this one, supposedly it will show you not the image, but shows you the value like this one. But of course, not 1, 1, 1, 2, 1, 3, not the location. But instead, it will shows you a array with intensity value. For example, 110, 120, 130, 140, 150, 00, something like that. Okay, so this is what when you double click this one, array underscore gray, it would show you something like this one. Okay, not this one and not the image. If you want to show the image, use im show a underscore gray. Okay, this is the basic algorithm to play around with the image. Image is normally processed as an array of metrics to read an image in Matlab, for example. So as I mentioned before, I am read to read an image. Kids.tif. Basically, this one, peppers.png. I'm not really sure with kids.tif, but peppers.png, cameraman, all those are built-in sample images with royalty free. So you can try to use it to try some example or sample algorithm. Okay, so let's say this one kids.tif is an example, or else you need to put the locations. For example, your desktop slash blah 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 location, your directory put your directory over here, that it will shows the image. Okay, WOS is actually to shows the some brief data, some brief informations from this one. Okay, so whenever you put WOS, then it will show the brief information as per this one. Okay, if you don't know, if you want to know a specific or a particular algorithm for Matlab, it's very easy. Basically, you just need to type in the Google search engine, maybe imread, put a space, and then Matlab. Then for sure, this command would be appear, and then you just click in and view what it is about. That's all. Okay, it's very simple. Okay, as I mentioned before, WOS is meant to give you a brief information regarding the image. So basically, why it is A? Because you declare it as A. If you declare it as B or C or D, whatever, it will show over here. And the size and the byte, the class, the grand total, how many elements using blah, blah, blah bytes. Okay. Image is normally processed as an array of metrics. In Matlab, the image is always being processed as an array, 2D array. Okay, as shows here is a 2D array. To read an image in Matlab, for example, you have the row column. So you need to put in, this is row number 193, and this is column number 80. So you just put in the row and column here and press enter. So it will prompt out like this one. Okay, like this one. And not prompt out this one only. Okay, but if you put semicolon, A193.80, you put semicolon, then nothing will come out. Okay, because semicolon, which means do not appear, do not show the answer. Okay, if without the semicolon, everything will prompt out. Okay, if you want to do programming, for sure you want to put the semicolon. Else, whenever you hit test run the code, a lot of things prompt out, and this will delay the process time. Okay, you can play around with this one. Row first or column first, but I believe this one is correct. Row followed by column, but it's good for you to reconfirm by your own. Okay. Image formations. Image that capture from a camera is digitized into bitmap image spatial sampling. As I mentioned before, in Matlab we only process the bitmap image, and instead bitmap image is very important for us to carry out, to perform the image pre-processing, post-processing, image segmentation, and etc. So since a digital image is consisted of picture element or pixel, each pixel is represented by a fixed number of bit to represent the color of that pixel. This bit is very has a close connectivity to byte, and byte has a close connectivity to size. So that is why the higher the pixel, the higher the number of bit, the higher the byte, the higher the size. Okay. So camera projections of a 3D scene into 2D scene. An image is always a 2D signal. So whenever, this is very common sense. You capture something in real life, real life, everything would be in 3D, right? So whenever you capture something else, it will form a 2D image. So this 2D image would be placed as this. Camera project a 3D scene into a 2D moving scene. So this is considered as moving scene. So in one image itself, all these are known as partial sampling, which means you have different sampling in one image. But later on, you can have temporal. Temporal is when you deal with time constraint. For example, this is first frame, second frame, third frame, fifth frame, number 6, number 7, and da da da. Okay, let's say you have 20 frames. So the information with regards to 1, 2, 3 until 20 would be the temporal sampling. And the pixel value in one images, which means the first set pixel, second, third, fourth, fifth, and da 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 da, so on until the very last pixel. This is known as spatial sampling. So you have to know the difference between spatial sampling and temporal sampling. Basically, spatial is talking about the space, and temporal talking about the time dimensions. Increasing the sensor sampling point will increase the number of pixels used and thus increase the resolution of the image. So this improves image quality, increase the bits per pixel, will increase the number of color that can be displayed. So increase the bit is actually same like increasing the bit is same like increasing the resolutions, which means you can have more 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 sorry more intensity value to represent a specific color. For example, you want to represent black and white, so you only can 0, 1, right? So since you have 0 white, 0 and 1, so you would expect you have a black color one side and white color another side. But if you have this is only black and white image. If you have a grayscale image 0 to 255, so you can have a transition from dark color, light gray color, and white color. So sort of shading over there. Okay, so you can use this kind of shading to present more details. So all this shading is depends on the number of intensity value over here. If you have only 1, 0 or 1, so basically not much you can choose, either black or either white. There is no intermediate value. But with this grayscale, you have a lot of intermediate value, which is 0 to 255. Okay. So the resolution of image increase with the number of pixels. This is what I mentioned just now, like your TV, HD TV and UHD TV. So the higher the HD value or the higher the definitions, basically the greater the pixel is required. So let us at this one, it is 4 times. Let us assume it is 4 times 4. Anyhow, the total number of pixels is 16. Okay, so you can definitely see a bloggy feel, and perhaps when you compare with all the other image, you can know, oh, it is actually a sunflower. But let's say if you don't have a any of these, only this image itself, perhaps you cannot tell is this a sunflower or maybe squirrels, like jumping from one tree to another tree and etc. So this is why the pixel value is very important. So when you have increasing 32 pixel, so you can view a little bit more clearer, but yeah, perhaps still very blur like, and then this is considered okay, and then followed by this one, and this one. And for the last one, you can see the details very well. The positions of the uh, pedals, which one is longer, the texture on the pedals and etc. For this one, you cannot really see the texture. Okay, so this is the different lah. The higher the resolution, sorry, the higher the pixel value, the higher the resolutions. So there are now we are talking about types of image. So basically we have four basic types of image: binary image, 8-bit grayscale, 24 bits true color image, and 8-bit index image. So binary image is the one that I mentioned just now, only black or white, either way, 0 or 1. 0 for black and 1 for white. So this is the binary image. And 8-bit grayscale would be the very common, very common uh, image that we have, which is span from this is 0 or 1, this is 0 to 255. Grayscale 0 to 2550 representing the black color, and 255 is the white color. And 24-bit true color image, 24-bit, why it is 24-bit? Color images is always RGB. Of course, not all, I mean, not always RGB lah, but the most common one, the decent image would be RGB. Of course, there is another sort of LGP, LAB, and then the what else? HUE, YCBCR, many other different formats of true color image. But usually, the common one lah, we would say RGB, which is red, green, and blue. Red, green, and blue. Okay, an index image is also a color image, but index image is a bit different because it is dependent on the lookup table. It is like give you a code, and from the code, it is like give you a code. For example, this code is maybe a 1 2 3 lah. Okay, so it has another table, and you find the column 1 2 3 1 2 3, and it will tell you what color is it, the color code. Okay, so this is called index image. It is color image as well, but the way to interpret the color intensity is a bit different. So this would be the four basic types of image. Again, binary, 8-bit grayscale, 24-bit true color, and 8-bit index image. Why the RGB is 24? Because 8-bit each one. So total 24. So binary image. Each pixel is just black and white. 1 bit is used to represent each pixel with white color. It is usually used with image of text, fingerprint, and architectural plan. So basically, binary is the most basic and most simplest image. For example, your segmentation image. After you segment something else, usually it is in black and white. Depends on your application. Some people want to take the white color as the foreground, black color as the background, or vice versa. Excuse me. So basically, either way, as I mentioned just now. So for this one, the 0, the black color is the foreground, and the white color, the 1 is the background. Okay, foreground which means something that you want, and background would be the background. So this one would be background, this one would be foreground. Okay, so that is why you can observe the alphabet H, right? So each pixel is just black and white. 1 bit is used to represent each pixel with white color. It is usually used with image of text, fingerprint architect, like this is because this one save a lot of space. So usually for text file, we don't use RGB, we don't use grayscale, we just use black and white. Okay, because both of it, no matter black and white, RGB, and also 8-bit grayscale, you still presenting the same thing. But what is different would be the size of the text file. Okay, that is why in order to save space or to save the size of the file, so we will select for black and white. 8-bit grayscale image. Each pixel is capable of displaying several shades of gray, where black is 0 pixel and white is 255. So all the value between 0 and 255 would be the transition from black and white. Okay, you would suppose this one is dark gray, light gray, very light gray, and white. Okay, something like that lah. Okay, each pixel, the number of grayscale supported can be estimated as 2 power of n, where n bits per pixel, n bit per pixel. For example, 8 bit per pixel of an image, the image intensity can display 256 shades of gray. So that is why, I mean, the grayscale is actually 8 bit grayscale image, right? Why 8 bit? Because 2 power n. Okay, you will get 256. Okay, 256 would be the number of value over here because for image we start from 0, right? So 256 minus 1, which is 0. So you have the maximum value is 255. The minimum is 0. Okay, 0 is representing black color. So 2 power of 8, you will get 256. So that is why you call it as 8 bit. So grayscale image is typically used in newspaper, printed book, photograph, non-color. Because grayscale is non-color, it only has, I mean, from dark to white color. That's all. It don't have any, red color, blue color, green color. No. So for sure, it is non-color. And then resonant image, MRI, and CAT scan, CT scan. Okay. So basically, MRI, CT scan, all those are grayscale image. So 0 will represent the black color, and white color. Actually, there is another line over here. So this is white color, which is 255, and the rest will be the shading of the value range between 0 and 255. So this is another image. We call it as Lena. Perhaps this girl named Lena. This is another example image from the Matlab. So image display different shade of gray. So this is a grayscale image. So we will have black color, light gray, dark gray, very light gray, and dark gray. All these are between 0 to 255. An 8-bit grayscale image is represented by a 2D array. Again, all the images are in 2D. It depends on how many layers it has. For example, black and white, you have only one layer. Grayscale, only one layer. But for RGB, because you have red, green, and blue, so you have 3 different layers. Okay, so yeah, that is it. So basically, you just superimpose red layer on the green layer, on the blue layer, so you will get a color images. Okay. But in Matlab, whenever you separate the RGB in different channel, you do not expect to see red color. I mean, for example, you break down RGB an RGB image into red, green, and blue, channel. You wouldn't expect to see red color in red channel, blue color in blue channel, or the green color in green channel. But instead, you will still observe something like this one, a totally grayscale image, but with different range. With different intensity range. So of course, the intensity range for RGB still ranges from 0 to 255, just that the value of a specific location is different. So whenever you combine, you would get 3 different values. So for example, for this one, let's say for the first value here, origin, maybe 0. Let's say this is, if this is a grayscale image, you would expect to have maybe 100, let's say lah, example. But if this is a RGB, whenever you declare this one in your Matlab, for example, A is equal to IM read your directory, okay, and then A 0, 0, 0, okay, that's all. So whenever you hit the enter button, it will shows the answer lah. A and S equals to blah blah blah. Okay, so let's say this is a grayscale image. It will shows only one value, for example, 100. But if let's say this is the RGB value, it will still show one value because it will show the last value R, G, and B. It will show the B value. Okay, so you have to put it in this way, if not mistaken. 0, 0, 1 equals sorry, A 0, 0, 1, then A 0, 0, 2, A 0, 0, 3. Else, if you want the Matlab to show everything in one shot, you can use A 0, 0, semicolon. Okay, something like that. So for this one, it will show the value of R, value of G, and value of B. And for this one, it will show all 3 values. But whenever you only put it in this way, A0, 0, so it will show only the last value, if not mistaken. I've forgotten is the last value or the first value. Okay, so this is the trick in Matlab. Okay, how Matlab is how Matlab actually process the data and also present the data. So let's say you put A00 and it only shows one value and obviously the input image is color image. So please do not say that, only one value. No. Yeah, just that the way the Matlab is processing the data is a bit different. Okay. So an 8-bit grayscale image is represented by a 2D array of pixel value that represent the grayscale intensity of a sample point. So grayscale image with color depth of 8-bit, 2 power 8 equals to 256. Remember, you have only 256. This is the maximum value, and then 0 is occupy one value, and then the rest 255. Okay, so the max would be 255. There is no intensity 256. Okay. Above can be displayed 256 different grayscale intensity ranges from 0, which is the black color, the black color, and 255 the white color. So 24 bits true color image. Each pixel value defines the sample color point color. The color is formed by the combination of red, green, and blue primary color. Each color component has a value of 0 to 255. So a total of 2,563 equals to 60 million color. This is the combinations, like the combination of possibility, the P possibility, what you call permutations, right? Permutations, I think back to Form 5, we did learn this. Forgot what chapter already. Okay, so that is why when you have a combination 0 to 255, another combination 0 to 255, another combination 0 to 255, which means you have 256 and 256 and 256. So basically you have a lot of value okay, for you to, many different combinations. And all these combination can create all the color as you can observe nowadays, which means any color, okay? Any color is depend, for example, the color of red, maybe you have R, G, and B. R value is very high, and this is very low. Cannot very low because if everything very low, this would be a very, very dark red color, maybe 100, something like that. Okay, and let's say you have a forest green, maybe you have a 100 blue color. RGB, this is B. RGB, because this is forest green and the blue color and green color must be higher, should be around this one, something like that. Okay, so this is how the color being formed, yeah, by using just the gray value 0 to 255 for red, green, and blue, 3 different layers. So 8 times 3 is 24. That's why then 4-bit. So this image is an example from Matlab, which is called peppers.png. It's a example sample image lah. Okay. So basically, whenever you this one highlight the value of the red channel, green channel, and blue channel at a specific location. Why this value is between is 0 point something else, because this value is being normalized. It's like if you have 180, let's say red is 180, green is 140, blue is 100. So basically you divide by 255, divide by 255, divide by 255. So you will get a value within 0 to 1. So this is so-called normalizations. Okay. This normalization is somewhat important, especially when you involve the calculations of conversions from one color model to another color model. Because if you use the value from 0 to 255 to calculate, perhaps you will get a wrong answer. So sometimes it's important for you to check if the formula require you to normalize or not. Some yes, some no. So please ensure that you aware of this one. Normalization is very important. Elsewhere, to calculate. I mean, you're working all correct, but at last the answer is still the wrong one. Why? Is because you forgot to normalize. Okay. This is a sample image of 24-bit true color image. So 8-bit index image. Typical image only has a subset of 60 million possible color. The image file contains an associated color map. This is what I mentioned just now. 8-bit index image is also a color image, just that it is not like the RGB. It has 3 different values. No, but instead it will only give you a code, and from the color map, you need to, or sometimes we call as color palette. So from the color map or color palette, you will need to find the code and get the pixel value. So each pixel value has an index value. This is the so-called code that point to a corresponding color in a color map. So let's say this is a 8-bit index color, but in this one, it will only give you a value, which is number 5 here. This is the index value. And from the index value, you need to find the color map. This is the color map. And you need to find value 5, and you get the value. This is 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. So this would be the value of R, G, and B. Okay. So, but in this image, it did not give you this value, but instead it gives this one, only the index value. So from this index value, you need to refer to the color map and get, according to code number 5, get number 5 and get the value. So this will be your R, G, and B value. Okay. And again, this one is being normalized, which means it is in a range of 0 to 1, not 0 to 255. Okay. So index value of 5 is corresponding to the value of 0.2902, 0. Blah, 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 blah in the color map. Okay. So this is how you retrieve the data from the index image. It's a bit different. Okay. So I think I will stop here. We will continue image quality in the next lecture. And for the tutorial group, 16 students, today we don't have tutorial, remember that. Please join the tutorial group next week from 4:30 to 5:30 together with the group with 14 students. So next week we will have class from for both, tutorial from both the groups, and I will only upload the tutorial on Monday. Okay, usually I will upload the tutorial on the same week Monday. So you have 4 days to do that, okay? And I expect you all to do the tutorial because I will ask randomly to share your screen and to show the answer, okay? Don't worry, the tutorial question is very simple. And if in case you don't know how to do, it's fine. Just let me know. But I don't think everyone don't know to do that, okay? Because it's really simple, okay? So any question from the floor? No. Okay. So if you have any question, either WhatsApp me or email me. I will respond you very soon. And no, so that's all for today. Thank you. Bye bye.